Hi guys, this is your lesson on 5-1 monomials. This whole entire lesson deals with simplifying monomials. So we have negative exponents, you're going to be multiplying and dividing them, raising powers to powers, and all of that good stuff. So the first thing we're going to look at is negative exponents. Your final answers for all of these problems should not have negative exponents. You can only have positive exponents. So the very first thing that we need to do is get rid of these negative exponents. A negative exponent just deals with movement. So this x to the negative fourth, I'm going to go ahead and write as x to the negative fourth over 1. And what happens is to get rid of that negative exponent, what you're going to do is you're going to move the term that has a negative exponent. So negative exponents deal with reciprocals. So I'm going to take this and move it to the bottom. And what ends up happening there is since I move it to the bottom, my exponent is now positive, which is exactly what we want. So I have x to the fourth on the bottom. You can't really have an empty numerator, so I'm going to go ahead and put a 1 there. So your final answer for this is going to be 1 over x to the fourth. For the second one, doing the same thing, except my y to the negative fifth starts in the denominator. So what I need to do is I need to take this and move it to the numerator. That 3, we don't really have to worry about moving because it does not have a negative exponent. So my 3 stays in the numerator, and my y to the negative fifth joins it in the numerator as y to the positive fifth. So your final answer for letter B is going to be 3y to the fifth. Multiplying monomials, you're just going to multiply each of the terms together. So I'm going to go ahead and start by multiplying my fraction. So when you multiply fractions, you're multiplying straight across. So 1 times 3 is 3. Over 2 times 4, which is 8. So I have 3/8. 3/8 cannot be reduced, so I'm just going ahead and leave it like that. For my variables, when you multiply variables together, what you do is you add the exponents. So this x without an exponent is the same thing as x to the 1. So I have x to the 1 times x to the fifth. So essentially I have 6 x's there, so that ends up being x to the sixth. For my y's, I'm going to add my exponents as well. So I have y to the 6th times y to the 4th is going to be y to the 10th. Let's fix that. And then z squared times z to the 7th is going to be z to the 9th. So your final answer for this is 3/8, x to the 6th, y to the 10th, z to the 9th. For letter B, again, the numbers I'm just going to treat as regular numbers, so I'm just going to multiply the numbers. You do not have to worry about this negative because it is not a negative exponent. So you're just taking negative 5 times positive 3, which is negative 15. So what I mean by that is you don't have to move this to the denominator because, again, it's not a negative exponent, it's just a negative number. For my variables, I'm going to go ahead and add my exponents. So x squared times x to the 4th is going to be x to the 6th. Y to the 5th times y cubed is going to be y to the 8th. So final answer for this is going to be negative 15, x to the 6th, y to the 8th. When you're dividing monomials, what you do is you subtract your exponents. So all of these properties you have to memorize essentially. So over here, we multiplied our monomials, so we added our exponents. When we divide our monomials, we are going to subtract our exponents. I like to pay attention to the positions of my variables. That way I don't have to deal with negative exponents. So here's what I mean by that. I have x to the 8th and then x squared on the denominator. So I have 8 x's up here, 2 x's on the bottom, so it means I have more x's on top than I do on the bottom. So once I simplify this, my x is going to stay in the numerator, because again I had more x's on top than I had in the denominator. I'm going to go ahead and subtract my exponents, so 8 minus 2 is 6, so that's going to leave me with x to the 6th in the numerator. For my y's, I have y to the 7th in my numerator, y cubed in the denominator. I'm going to go ahead and subtract my exponents, so that's going to be y to the 4th, and my y to the 4th is going to stay in the numerator because I had more y's in the numerator than I had in the denominator. I put the 1 there because I didn't want to have an empty denominator. Your final answer for letter A is going to be x to the 6th and y to the 4th. For letter B, I have 4 a's on top, 10 a's on the bottom, so I have more a's on the bottom than I do have in my numerator. So that means I'm going to be left with a's in the denominator. I'm going to go ahead and subtract my exponent, so 10 minus 4 is 6, so I'm going to be left with a to the 6th in my denominator. This b has an exponent of a 1, So again, I have more b's in the denominator than I have in the numerator, so that means my b is going to stay in the denominator. I'm going to go ahead and subtract my exponents. So 3 minus 1 is 2. So I'm left with b squared in the denominator. For my c's, I have more c's in my numerator, so c's on top. Subtract my exponent, I have c to the 5th over c squared, and that's going to be c cubed. So there's your final answer for B. When you're raising a power to a power, what you want to do is you're going to take each one of these terms and raise it to that power. So this is the same thing as 4 squared times x cubed squared times y to the 8th squared. 4 squared is just 4 times 4, which is 16. X cubed squared, when you raise a power to a power, you are going to multiply your exponents. That becomes x to the 6th. So we have 3 properties so far. When you multiply your monomials, you add your exponents. When you divide your monomials, you subtract your exponents. When you raise a power to a power, you multiply your exponents. So this one ends up being y to the 16th. Same thing when you have a fraction over here, so you're going to raise each of these terms to the 3rd power. So I have 4 cubed times x cubed cubed times y cubed over 2 cubed and z to the 9th cubed. 4 cubed is 4 times 4 times 4, which is 64. X cubed cubed is going to be x to the 9th, because I'm multiplying my exponents. Y cubed is just y cubed. 2 cubed is 2 times 2 times 2, which is 8. Z to the 9th cubed is going to be z to the 27th. You always want to check to see if this can be simplified further, which in this case it can, because you have 64 over 8. That reduces to 8. So my final answer for this is going to be 8 x to the 9th y cubed over z to the 27th. Your negative exponent over here basically means you're taking each one of these and raising it to a negative power. Now, what we did with negative exponents over here was we created movements. So we took this, moved it to the denominator, took this denominator, moved it to the numerator. What's happening to this is this entire thing is being raised to the negative exponent. So what I can do to get rid of that negative exponent is I can take this entire fraction and flip it over. So this becomes x to the 7th over 2y to the 4th, and now it's being raised to the positive 2nd power. So again, to get rid of that negative exponent, I just took the reciprocal of this entire thing, and then now I have a positive exponent. Now I'm going to raise each of these to the 2nd power. So x to the 7th squared is going to be x to the 14th. 2 squared is 4. And then y to the 4th squared is going to be y to the 8th. So we have x to the 14th over 4, y to the 8th. For the 5th example, what we're doing is we are combining all of these properties together. So if you notice, we have fractions over here, variables on top of each other, we're raising powers to powers. So you just kind of have to take it one step at a time. What I like to do is I like to simplify what's inside my fraction or my parentheses first. That way I can get that simplified before I start raising everything to the 2nd power. So 4 over 16 reduces to 1/4. X cubed over x to the 9th, well, I have more x's in the denominator, so my x is going to stay in the denominator. I'm going to go ahead and subtract my exponent since we are dividing, so that's going to be x to the 6th. Y to the 6th over y squared is going to reduce to y to the 4th, which is in my numerator since I had more y's in the numerator. And then the z has an exponent of a 1, so I have z to the 1st over z to the 4th. That's going to reduce to z cubed in my denominator because I had more z's in the denominator. And I still want to square it because we have the square out here. Now I'm going to take each of these terms and raise it to the 2nd power. So 1 squared is just 1. Y to the 4th squared is going to be y to the 8th because I'm raising a power to a power, so I multiply my exponents. 4 squared is going to be 16 Please do not multiply your 4 and your 2. You're taking 4 and raising it to the second power, so it's 4 times 4. Do not apply to the rules for exponents for the rules for numbers. Numbers you just treat as regular numbers. So a lot of students, what they do is they take y to the 4th and square it, and that gives you y to the 8th. Since they multiply these two, they have a tendency to want to multiply the 4 to the second. This, again, is just a number, so you're raising 4 to the second power, which is just 16. It is not 8. X to the 6th squared is going to be x to the 12th. And finally, z cubed squared is going to be z to the 6th. So here's your final answer for the first one. For letter B, again, I like to simplify what's on the inside first before I start messing around with this exponent. So I have 10 over 5, which reduces to 2. A squared over a to the 9th is going to leave me with a to the 7th in the denominator, because I have more a's in the bottom. B to the 1st over b to the 4th is going to leave me with a b cubed in the denominator, because I'm subtracting my exponents. And then c to the 5th over c to the 6th is going to leave me with a c to the 1st power, because I'm subtracting my exponents. And I have more c's on the bottom than I had in my numerator, so my c is going to stay in the numerator. Now from here, before I raise everything to the negative 3rd power, I want to make this a positive exponent. So I'm going to go ahead and take this entire fraction and flip it over, and then my exponent becomes a positive 3. So my 2 is now in the denominator, my a to the 7th, b cubed, and c to the 1st is in my numerator. And then I can take each one of these terms and raise it to the 3rd power. So a to the 7th cubed is going to be a to the 21st, because I'm raising a power to a power. B cubed cubed is going to be b to the 9th. C to the 1st cubed is just going to be c cubed. And then 2 cubed is 2 times 2 times 2, which is 8. Again, do not multiply the 2 and the 3, because the number you still need to treat as a number. So final answer is right here. Finally, for scientific notation, hopefully you remember doing scientific notation in science and in Algebra 1-2. You basically need to create a number that's between 1 and 10, and then you are going to have it being multiplied by 10 to some power. So I'm going to go ahead and ignore the zeros for now. I need to create some number between 1 and 10. So using the 7, 5, and 6, I'm going to create 7.56. And I'm going to multiply that by 10 to some power. To figure out what that power is, I'm just going to count. So there's a decimal right there. I'm going to count how many units I have to move it over until my decimal is in between the 7 and the 5. So that's 1, 2, 3, 4, 5, 6, 7. So that's going to be 10 to the 7th power. So 75,600,000 is the same thing as 7.56 times 10 to the 7th power. For this one, I'm going to create a number between 1 and 10 that's in between, I'm going to create a number between 1 and 10 using the 4, 9, and 8. That's going to be 4.98. And I'm going to multiply it by 10 to some power. So again, I want to move the decimal over until it's between the 4 and the 9. So that's 1, 2, 3, 4, 5. So this is going to be to the negative 5th power. So this exponent is negative because we were dealing with a really small number, so we were dealing with a decimal. This exponent over here is positive because we are dealing with a really, really big number. When you're multiplying and dividing and raising powers of scientific notation, you can go ahead and do this on the calculator. It does deal with your properties of exponents. So over here I'm going to go ahead and multiply these two numbers first. So 2 times 6 is 12. 10 cubed times 10 to the 9th, since I'm multiplying them, I'm going to go ahead and add my exponents together. So that's going to be 10 to the 12th. This is not in scientific notation because this number has to be between 1 and 10. So what you can do for scientific notation is you can take this and expand it out so it looks like one of these numbers, or you can just move the decimal over once. So this becomes 1.2 times 10 to the 13th power. And if you were going to put this in the calculator, you can type in exactly how it looks. So 2 times 10 to the 3rd times 6 times 10 to the 9th. And hopefully I get 1.2 times 10 to the 13th. I do. So I have 1.2 times 10 to the 13th. For letter B, I'm going to go ahead and take this and plug it right into my calculator. You can do this on any calculator. You do not need a graphing calculator for this. And I get 7.5 times 10 to the 7th. My calculator didn't give it to me in scientific notation, so I had to count my zeros. For this one over here, I'm taking 9 times 10 to the 6th divided by 3 times 10 to the negative 4th, and that gives me 3 times 10 to the 10th. And then finally for this one, I have 4 times 10 to the negative 7th being raised to the 2nd power. That's going to give me 1.6 times 10 to the negative 13th. All right, so that's your lesson for section 5.1.